Okay, here's these two problems that we're going to do. I guess we'll start with this one. Well, I don't have enough room, so I'll have to make some more ratios. But okay, so where would I begin on a problem like this? Again, when I see the distributive rule, do the distributive rule. I know I've said that probably 50 times now, but it's worth saying again. You don't have to have a master plan. You don't have to see exactly where it's going to take you. But if the distributive rule is there to be done, do it as a reflex. You reach on the stove and you pick up a hot pan, ow, and you let go. You don't do a whole lot of thinking first. You just let go. Just do the distributive rule. So here we get negative 10x minus 5. Be careful of the negative signs at all times. Divided by 3 plus, I think that's a stray negative sign there. 6x plus 2 divided by 5 equals 2/3. X plus 1/2. Okay, that very, very easy. No problems. Probably not really much to be said there. Here's where I take a slightly different approach, and my reasons for it is it helps you to practice really important skills. And one of them is, if you don't like division, well, good. So we want to write division as multiplication. What's underneath every whole number? A 1. How do you divide by a fraction? Flip and multiply. So I'm going to rewrite the problem in a way I'm saying I don't like division, and I want to write it like multiplication. So this is 1/3 times negative 10x minus 5 plus, and I'll do the same thing here, 1/5 times all this. Look at the right side. Right now, I don't know what to do with it. What do we do? It'll just come along for the ride. So 2/3 x plus 1/2. Now, of course, look, the opportunity exists to do the distributive rule. So who can resist? Let's go ahead and do it. This times this and this times this. Negative 10/3. Is that visible on the screen yet? X minus 5/3 plus 6/5 x plus 2/5 equals 2/3 x plus 1/2. Now I'm going to need a little more room, so I'll leave this here. I'm going to erase what's above it. And this is a separate problem, right? So I'll leave that there. Hold on a second. Here we go. I was thinking, while I'm doing this erasure, well, I just erased it, but you can go back. You can just run the video back, rewind it a little bit. Where did I get all these fractions? Make sure, there's no careless errors, silly mistakes. Now let's combine like terms. Why? Because I'm always trying to combine like terms if it's possible. So do the distributive rule whenever you can. Rewrite division as multiplication. Combine like terms. Whenever those things are there to be done, go ahead and do them. So let's get this plus this. And I'm going to keep doing this. I'd like to pretend that there's a classroom full of all of you. So when I say negative 10/3 plus 6/5, I want to wait. Again, I never really know how long to wait. 1 second, 10 seconds, a minute, until everybody comes up with an answer. But the answer is, wow, now you don't know it, but I almost wrote down the wrong answer. In my mind, I was thinking negative 50 plus 18. And negative 50 plus 18, sure enough, is what? Negative 32, but I almost wrote down negative 38. So, hey, everybody, anywhere, anytime. Anybody, anywhere, anytime can make a silly mistake. It happens. It can be frustrating because you get the wrong answer and you don't know where you went wrong. But at any rate, let's take a look at that again in negative 32 15ths x. And then negative 5/3 plus 2/3, negative 19 15ths equals 2/3 x plus 1/2. Now here's something I notice. These are not terrible numbers. These are not bad numbers. These are not difficult numbers. But they're getting close to being bad numbers or difficult to work with numbers. They're getting close enough that it can be a little bit unnerving. Now, what am I going to do at this point? Well, I want to get x's on one side and numbers on the other. It doesn't matter what side you get the x's and the numbers. That's your call. You make that decision. If a equals b, b equals a. Anytime you want to switch sides, a equals b, b equals a, you can do it. I normally get x's on the left. However, here's something I noticed, that if I get this x over on this side, I'll only be dealing with positive numbers. And you might think, well, that's easier to deal with. Well, then I'd get this 1/2 over on this side and have negative numbers. So I don't really see a particular advantage to doing that. So let me go ahead and get the x's on the left and the numbers on the right. Now, let me write this in a way that sometimes I might write this. I'm going to subtract 2/3 x from both sides. So negative 32/15 x minus 2/3 x. And let's add this number to both sides. So we'll get 1/2 plus 19/15. Depending on how awake I am or depending on how energetic I feel, by writing this down, it lets me see these grouped together in a convenient visual way. Because now I'm going to add like terms. So we're going to have to do negative 32/15 minus 2/3. Get rid of that little space here. Now, notice what's happened here. Again, the numbers are not terrible, but they are more difficult. They're outside the multiplication tables. So we have to do this. Now, I've said this many, many times now already in these videos, whether you want to do it in your head or write it down on a piece of paper, or ultimately, I guess you could use a calculator. That's really up to you. But somehow or another, you have to do it. The way I think through it is negative 32 times 3, what, negative 96? And then from this, we would get negative 30. So I have to think, what the heck is negative 96 minus 30? And that should be negative 126, or I think it's negative 126. And now, okay, I'm glad I did this. I was about to write a fraction down, which is not reduced. Is it the end of the world? No, it's not the end of the world. Will I still get the right answer? Absolutely. But it'll make the problem more difficult. It'll just make more work. Now, I was toying with the idea right now of showing you. I'm not a big fan of shortcuts, and I'll tell you why. Because a lot of shortcuts, they don't work all the time. They may have limited application. So if you learn a shortcut, it could leave you stuck. However, there are some nice shortcuts. There just are. And here's one. When I see this, I notice that 15 would work for a common denominator. The obvious question is, how did I notice that? And the answer is, I could give you an algorithm, but the real answer is I just happened to notice. So looking at this right here, yeah, I'm surprised I didn't notice that right out of the gate. But hey, you know, what can you do? Right? So I said I wasn't going to show work on fractions, but I kind of can't resist. So over here in the corner, is this visible? Let's take negative 32 over 15 minus 2 over 3. If I use 15 as a common denominator, we'll get this. And that's negative 42 over 15, which is also reducible because 3 goes into both those. And 3 goes in here, what, 14 times? So 3 goes in here 5. So 14/5 x. Now that's a lot easier than what I started to write down. That's a lot easier. And then over here, we don't have so much of an issue in terms of reducing, but we still have to do, what, 15 plus 38? So what's 15 plus 38? 43 over 30. The final step, we'll divide both sides by this coefficient, which means flip and multiply. So let me go ahead and write this down. Since maybe I'm having one of those days here. 5 goes in 5 once, 5 goes in 5 6 times. So x equals 43 over, what's 6 times 14? 84. So there's the answer. Did that make it on the screen? Now let me write it up here. So x equals, get a better marker, 43 over 84. Again, I really like this kind of problem. I think it's a really good kind of problem for you to practice. You'll find these again in chapter 2. Let me see here. I don't want to click off this. I think it's 2.4. It's 2.3 or 2.4. You can't miss them because they have this characteristic look to them. But they're great because you have to do a lot. I mean, this gives you a tremendous amount of practice. You're dealing with fractions, distributive rule, combined-like terms, getting x's on the left and right, maintaining your focus, building up some level of endurance. This problem had a lot to do, so you couldn't quit in the middle of it. Okay, let's go ahead and do this next problem. So more or less, this should go the same as the one we just did. I'll start with the distributive rule. 12x minus 4 divided by 5 plus 3 times 2 is 6, 15x divided by 4, and you know, that's nice. I guess why is it nice? Because I'm really only dealing with arithmetic or calculations dealing with whole numbers, so that's pretty nice. Here's where I, in a sense, I reject division. I don't like division, so I'm going to write it as multiplication. So let's write this as 1/5 times 12x minus 4 plus 1/4 times 6 plus 15x equals 1/3 x minus 1. Okay, we'll do the distributive rule, 12/5 x, just rolling right along here. No problems. Make sure we reduce fractions. There's a problem here because I can't read what I wrote. Oh, that's a 15. So 15 fourths x equals 1/3 minus 1. Let's combine like terms. We have 12/5 plus 15 fourths. Now, like I said, I think it was last week, these problems, the numbers can get out of hand, and they can get out of hand pretty easily. This isn't out of hand, but it's enough to give you pause, and you have to think a little bit, because what I'm going to have to do here, I'm going to have to take 48, and I'm going to have to add to that 75. Now, 48 plus 75 really is not the end of the world. But in the middle of a problem like this can seem, you know, like a lot of effort, especially when I'm making a video and talking at the same time and looking at this and thinking about what everyone's thinking. This can seem quite overwhelming. Hey, if worse comes to worse, I mean, you look at this right here, and I'm always interested in how someone might think of this. I might think of this as, for example, I could pretend this is 50 for a second and add that to that. That's 125. But then subtract 2, so 123. So the answer is 123. But if you want what you learned as a little kid, 48 plus 75, that still works. And you could use a calculator too, honestly, of course you could. And you get the right answer. So 5 plus 8 is 13, carry the 1, 5 and 7 is 12. No matter how you slice it, it's 123, but you need to do that. Don't let that stop you. Don't let that defeat you. So 123 divided by, what was our common denominator, 20, x. And then these two right here, let's see, negative 8 plus 15, so plus 7/10. So, okay, so not too bad. And over here, 1/3 x minus 1. Hopefully I'll stop talking about this one of these days, but I do want to continue to talk about this. Notice what is the most difficult thing that I've done so far, by a long shot, was adding these two fractions. What was the most difficult thing in doing this algebra problem was dealing with the fractions, but they have to be dealt with, and you have to do it. There's no getting around that. Let's see, where am I on the board? Let me erase this out. I'll pop up. I'll leave this here. This you can always review to get back to. I guess it's one of the nice things about video. So now let's get x's on the left and numbers on the right, or the other way around, depending, you know, what kind of mood you're in. Let's go ahead and subtract 1/3 x from both sides, and we'll subtract 7/10 from both sides. So I'll get 123 20th x. Let's see, minus 1/3 x equals negative 1 minus 7/10. You don't have to write this down. I'm doing this because I think maybe it's a good idea right now. But if you want to just do, you know, any of these steps, if you want to do in your head, that's fine. Do as many steps as you want to in your head. I can't imagine you could do the entire problem in your head. That would be rather impressive. Wait, maybe. Excuse me. So let's go ahead and do this. Now, again, I notice, look, let's combine like terms. In doing this, 123 over 20 minus 1/3, I'm going to have 169 minus 20. Now, every time you get a number over 100, it somehow may make you feel like you've made a wrong turn or made a mistake. Not at all. You start getting numbers in the thousands, because of the way I'm going to set problems up, you maybe have made a mistake. I'm going to definitely try to keep numbers under 1,000. Maybe I won't always be successful, but almost always we will not be dealing with numbers over 1,000. So at any rate here, 149 over 60x equals, and then this negative 17 over 10. We'll flip and multiply, so negative 17 over 10 times 60 over 149. At least we get a little bit of canceling here. 10 goes in there once, 10 goes in there 6 times. So x equals, wait, before I continue, maybe 17 is a prime number, but maybe 17 goes into 149. I don't walk around having that information in my head. I don't even know if 149 is a prime number off the top of my head. It sort of looks prime-esque to me, but I wouldn't bet my life on it right now. But with a little bit of thought, which I was just doing right now, 17 doesn't go into 149. So 17 times 6, I always say I think it's negative 112 because I don't walk around knowing what 17 times 6 is. I don't. It's something that I have memorized. I guess for me, I quickly thought, well, that's 60 plus 42. And of course, it's negative. And, oh, hey, it's not 102. It's interesting. Maybe I had a subconscious alarm that went off that I made some kind of a silly mistake. Yeah, 60 plus 42. What's 60 plus 42 is 102. 6 times, I'm checking my sanity here. 6 times 10 is 60, and 6 times 7 is 42. So negative 102 over 149. And there's the answer. I hope you got those right. I'll be posting another video later today, and we'll be talking about inequalities. Inequalities are not a particularly big deal if you've got this under control. As long as you've got this under control, we can do inequalities, no problem. And then we'll go on ahead to graphing. And honestly, we can do graphing. The graphing that we're going to do is we're only right now going to be graphing fairly easy linear equations. That's chapter 3. If you can do this, if you have these skills, dealing with fractions, distributive rule, combining like terms, getting x on one side, say the left, and numbers on the other side, you're going to go through the rest of that smooth sailing. There won't be any problem. So make sure that you've practiced a lot of the linear equations in chapter 2, particularly what you see in 2223 in chapter 2. Okay? So that's it for now. Video later on today.